Good afternoon, everyone. If you saw my earlier video, you know what this is. This is a clapper, but this isn't just any clapper. This is an original 1984 design clapper. Technology Connections had a video about this up, but he didn't have the original one, and I just fortunately was handed this by a friend of mine the other day, and I recorded a really quick video looking at it. I have the clapper, I have the manual, which I looked at a little bit there. Also, copyright in 1984. So this is an original one. Do we have a patent number? No, we get US patent number pending. So patent pending, clapper from 1984. This one, well, I checked it briefly and it doesn't work, but what I want to do is I want to plug it in and see what's going on with it, and then I'll open it up and see if I don't think I'll be able to fix it, but I'm going to try, and at least we'll get a look at the insides of it. So let's get this out of the way. Let's bring in a power bar, just to go over the controls, I guess, if you want to call them that, on this. You have one outlet with a hand on it that says 300 watts max. That I think is the switched one. Well, the manual tells me it's the switched one. Then you have one labeled 960 watts max, which is an unswitched outlet, and that has a little lightning bolt on it. Nothing around it. The microphone must be in here somewhere, and we have a little window for a probably a neon light inside. So I did plug this in before at the office and got nothing. Let's try it here. There we go. Doesn't want to plug into the power strip. It's got a little lip on the edge designed to go around the outlet plate. And I guess that the second outlet here is so that you don't entirely lose your extra outlet. So let's just push this back a bit. We'll bring in a meter, and I just want to see what we see. So let's try the unswitched one. And you can't see that because I've got my hands over it. 116 volts, which is normally what we would get up here in the afternoon. It'll pop up closer to 120 in the evening. So let's try the clapper outlet, and it is on. Okay, so let's try some clapping. Nothing seems to be happening. And I would, at the office, mucked around with this. Now, it may mean it needs a load on it, but my guess is that the whole thing is rather dead. So let's have a look inside and see what we can see. Now, I'm not entirely sure how to get into this. This looks to be one molding on the side, and it looks like it's along here. So I think I'm going to start with just trying to, maybe we'll just give it a little nudge with a screwdriver just to see if this one will fit. Just to see what's going on. I mean, I suspect that this whole thing, this was a very large screwdriver for the purpose, but it was on top. My guess is it's actually glued with pillars inside, so I think this is going to be destructive. Let me look for a spudger. Now we have a more reasonable screwdriver, slightly. Where did the spudger go? There we go. Really ought to consider buying new ones. These have had the covers come off. Oh, it's clipped. Look at that. We're going to get into this non-destructively. So I'm going underneath it, and I'm using the spudger to release the clips. And I think we're in. We are. Okay. So what do we got? We'll get rid of the large screwdrivers. They were not necessary. So we've got, can we get this whole board out? Look at that. Wow. So we've got an IC, two ICs. Wait, one, two. There's the microphone. Some large power resistors there, and heatsink. We'd have to get this heatsink up in order to see what's underneath. I did have a quick look to see if I could find a schematic for this. Without looking at the patent application, I didn't go quite that far. I don't know. Okay, I was worried that was Loctite, but it's not. It's just a whole bunch of conductive grease here. It's just the screws. We'll bend this. Is it MOSFET up, maybe? Okay, so we've got the heat sink. We've got a pot. And we've got a bunch of chips. Well, let me look up those chips. I think I know what they are. I mean, I don't know what they are. We have a diode. Well, I've managed to look up the chips on here and the triac. So this is a triac. This is a quad op amp. That I recognized. These I recognized as logic, but I don't know anything about that stuff, so I had to look them up. This chip here is a 7-bit binary counter. This is a 2-input NAND Schmidt trigger. That I think we can kind of understand how that might be used here. And this is a dual D-type flip-flop. So this is doing everything in logic. That's the op amp. Presumably the op amp sets a threshold. This counts the claps, I guess. And then these do the logic required to trigger the triac. Since it's a triac, I do wonder if maybe it might work if it was under load. But what could be bad here? Any of these chips, presumably, since 84. A triac could be bad. The power supply, everything. The only thing that I could really fix, would be this capacitor. The diode's very unlikely to be problematic. But if any of these chips are bad, or the triac's bad, I'm not going to order a triac to fix it. And I don't think I have something I could steal one out of. But so let's do the risky thing. Let's hook it up, put some load on it, and see if that works. Well, maybe I'll put it back together, put some load on it, and see if it works, if there's actually some load on this end. All right, well, let me put it back together. That's the easy thing. We can do that in a moment. I'll get this book out of the way. Just so you saw what I did before, right? This little heatsink goes on here. This is actually really fairly well thought out in terms of just stuff from that era. I could probably put some new heatsink grease on it, but I'm not going to bother because this is not going to be used. I'll tighten that down a bit. Okay, so we've got that on. It's straighter than it was. And then this goes through here. You can see that it's got little stops for everything. So that runs in here, and then this should just snap right back on, and we should have gotten into it non-destructively. And there we go. So I will go find a light that has, I'm trying to think what I've got with enough load maybe to get this work. I do have some dimmable, some LED bulbs that have dimmable bulbs in them. They should have a load resistor on that should hopefully pull enough current for the Triac. Let me see if I can find those. So after a little bit of futzing around, I have acquired a lamp. There's a little IKEA lamp here, and I found an incandescent bulb for it. And that's important because the clapper works. And this little hole isn't a light. It doesn't have one. That's the microphone. So let's try it. There we go. Clap on. Let's see if I can make it work off. There we go. It's still working from 1984. Oh, I'm no good at it. There we go. So, and you can see why this version of it, actually that works better. This one uses a single clap, not multiple claps. And look, tapping the plastic works as well as anything. Oh, clap on, clap off. So, it's a working clapper from 1984. Now, the reason I thought it wasn't working is I assumed that that was a light, but it's not. That's the microphone. So, yeah, the thing works. Now, the other thing, of course, is because the Triac is probably leaking some voltage across, or maybe it was on before. I don't know whether it's default. So there it is on. Let's unplug it. Is its default position on? No, it's off, but I could easily have made enough noise to turn it on. There we go, right? I could easily have made enough noise to turn it on while messing around with it. Let's turn down the sensitivity. There we go, now it's working properly. Okay, I'm not very good at it still. Anyway, there we go. Obviously the timing is important and whatnot. So, what's our conclusion? Clap on, clap off. Thanks very much for watching.